Government.
Then we can get everything.
Okay, so
Is that why there's no caffeine in the drinks on the...
so today we're going to talk about solving systems by elimination. So we've already talked about how we solve systems by graphing, okay, how we solve systems of inequalities using graphing, and how we solve by substitution. The third method that we haven't talked about is elimination.
Oh, really?
What does the word eliminate mean?
To get rid of.
To get rid of something. So our goal in elimination is going to be to get rid of something. Okay, so when we're talking about a system in general, what is a system?
Equation?
How many equations?
Two.
Two equations, and how many variables?
One.
Two. Right? We have an x and a y, two equations, two variables. Okay? So two equations, two variables. Same idea as what we've been doing, but today they're going to look a little bit different in the fact that they're stacked. They're going to be sitting on top of each other. So if we have something like 3x minus 2y equals 8, and negative 2x plus 2y equals negative 5. Okay, this is two equations and this is two variables, so this is definitely a system.
So we have to solve for y in this one?
Now, could we go back to what we've already learned and could we solve these for y and do something with graphing?
Yes.
Yes. Okay, but what if we get really weird fractions and then we're approximating? Okay, that's not going to be super great.
Yes.
Okay, so what if we consider substitution? Can we find a variable with a coefficient of 1?
No.
No, but could we do some solving and get something by itself? Yeah, but what if we get weird fractions? Okay, so this time we have this very specific setup of everything is sort of stacked on top of itself. So an x is on top of an x, a y on top of a y, an equal on top of an equal, a constant instead of on top of a constant. When we are in this format, elimination is usually a good route to go. Okay, and when we are solving with elimination, like we said, our goal is going to be to eliminate, to get rid of one of the variables. To get rid of a variable, we are going to look for, we are going to find a variable with matching coefficients. Okay, we want to find a variable
So 2 and 2.
that has a matching coefficient. So what's a coefficient?
Two.
The number next to the x or
The number in front of the variable.
So 2 and 2.
Okay, and we are going to ignore the positive or negative sign. That's going to be irrelevant for this first step. I mean, it's important. We need to consider it. It's not like it's not there. But to find the ones that are matching, it's not important. Okay, so if we look at the x's, what number's in front of this x?
3.
3. What number's in front of this?
2,
So those don't match, right? Those are different numbers. This has a,
negative 2,
and this has a,
2.
so, right? So those are both 2s. So this is where we are going to focus. Once we have picked where we see a matching coefficient, okay, we are then going to decide their signs. So if they have opposite signs, we are going to add them.
0.
This is the ideal world that we want to be in, that they are the opposite sign and that we can go to adding them right away. Okay, so this 2 is negative, this 2 is positive. Those are opposite signs. Now, we don't just want to add the variables because that creates an entirely different thing, right? We need to add these entire equations together. So we're going to add straight down, sort of like multi-digit addition, where you kind of go row at a time. So we want to add this entire thing to itself. So what is 3x plus negative 2x. If you're bad with negatives, you could just
-1.
pick up a calculator.
1.
Positive 1, right? You could just pick up a calculator and do 3 plus negative 2,
So 1x.
which is 1, and then you can throw the variable on the end. Okay, now most of you already told me what's a negative 2 plus a 2.
0.
And those go away, so we're not going to write them down. We eliminated them.
So you don't even have to put the 0.
So we're not even going to put the 0. Because we want a variable to go away. That's our entire goal. Okay, then we'll bring down the equal sign. 8 plus negative 5 is 3.
Oh.
X is equal to
Oh, I'm
Yeah, no, I mean, you could divide by this one here, right? But this is just telling us that x equals 3. And then my students are like, oh, why have you been making us do everything else? That was way easier. But this does come with a trade-off. Elimination has less work to find the first variable, but more work to find the second, because we're not done yet, right? We said the answer was finding the x and the y. So we need to take this value and we need to plug it back in.
Yes.
Right, we're going to substitute that back in for the letter that we solved for. Now, you can substitute into either of these equations. We don't have that nice, neat thing that happens with substitution where you just kind of plug it back in and you just, you know, you can do some mental math and you get an answer.
So wouldn't it
We don't have that.
Wouldn't it just be 1?
Hang on. So which equation do we want to plug into?
The first one.
Sure. So if we go into the top, what letter are we plugging in for?
X.
X. So this is going in for X.
Oh,
So instead of saying 3 times X,
3 times 3.
we're going to say 3 times 3
Which is
minus 2y equals 8.
Do we solve for y?
And then we have to solve this for y. So 3 times 3 is 9. Okay, and this is then a 2-step equation that hopefully we are able to solve. So we'll need to move a positive 9 by subtracting 9.
It'll be positive 1. Right? No, positive 2.
No, because we're dividing. So 1/2.
Oh, wait. I'm confused.
Right? We're not subtracting, we're dividing. I'm doing negative 1 divided by negative 2. And 2 negatives make a positive.
yes.
So what's another way that I could write this?
0.5.
3 comma 1/2 or 0.5 for all you decimal lovers out
Or
there.
x equals 3, y equals
Or x equals 3 and y equals 1/2.
8 divided by. Wait, you got 1/2?
Because you have to subtract the 9 first. Did you plug that 3 back in and get a 9?
Yeah, but I thought you couldn't subtract 9 with this.
Oh, you shouldn't have the x left. The x goes away, right? There's no x there, so that's just a negative 1. Yep. Okay. How do we feel about this one? Kind of, sort of, maybe? Okay, let's look at another one. And let's say the equation that we are given is okay, thank you. X plus 2y equals 3 and x minus y equals 6. Okay, so if we want to solve this by elimination, is it a system? Do we have 2 equations and 2 variables?
Yes.
Yes. Do we have that sort of stacked look?
Yes.
Yep. So we want to find a variable with a matching coefficient.
1 and 1. X and
So the x's, right? Do we agree that the x's both have a coefficient
Yes.
of 1?
Mm-hmm.
Okay, so now we're going to look. Is this one positive or negative?
Positive.
Positive. Is this one positive or negative?
Positive.
So when they are the same
They
sign,
cancel out.
nope.
No, they
Subtract.
They,
Okay,
Two.
so yes, when they are the same sign, we want to subtract, but there's a problem. Okay, my students really stink at subtraction. And most of you realize that, right? You'd rather work with addition if you can. We're gonna have to do more work with this tomorrow anyway, so right now it's gonna feel a little bit like extra work, but it's really not. We don't want to subtract. So if they are the same sign, what we are going to do is we are going to multiply the bottom equation
With everything else.
by -1.
Makes sense.
Because that's really adding the opposite. Okay, so I'm going to take this entire bottom equation, the whole entire thing, all the way through.
Well, this is like that one, we did this like a long time ago. Kind of.
And I'm going to distribute this -1. So this top equation is going to stay exactly the same. Andy, please don't. So this top equation is going to stay as an x plus a 2y equals a 3. Okay, this bottom equation, I'm going to multiply this -1 through. So -1 times 1 is?
Wouldn't it be -1?
Yep, -1x. -1 times -1 is?
1.
+1. -1 times 6, because this has to go to all 3 of them, is?
5.
-6. Don't add them, multiply them. And now we still have the matching coefficient, but now we're able to just add them because they are the opposite sign. And so if we add straight down, x plus a -x is
0.
gone,
Yeah.
right? That just cancels. 2y plus y is
Why?
3y.
3y. And 3 plus -6 is
-3.
-3.
And then do we divide from there?
This is something that we know how to solve, so we can divide each side by 3,
So 1.
and we'll get y equals -1. Are we done with y equals -1?
No, we gotta find the
No,
x.
because we have to plug it back in. You can plug it back in now to any of these equations. Which one would we like to plug back into?
Top.
The very top.
Yeah.
Which variable am I plugging in for? What letter?
Y.
Y, because that's what I solved for. So I now have x plus 2 times
-1.
-1
Which is gonna be
equals 3.
-2.
2, right? So now I'll have x minus 2 equals 3. And then x equals 5.
Yes.
How else can I write this answer?
-1.
5 -1.
5.
Right, why do I need the 5 first?
Because it's the y.
Because it's the x value.
Oh, crap. Yep, other way.
Yeah, you said it right, but then
Yeah.
So here's what I want to do. I know, like, we're rushed. I know with the delay, it's maybe not as much as we would like to do,